isn't going to work. Okay? If you only have that base on one side, it makes a lot of sense to just do log base 3 if you only have a base of 3. That's not going to work here. So we're going to go back and we're going to just take the log, plain log of both sides. So on number 1, one of the bases is 5, one is 4. So we're just going to take the plain log of both sides. And based on your log rules, the exponents will come out in front. You have to be careful, though. This is why these are even uglier. The exponents are not monomials, they're binomials. So when you bring them out in front, you have to keep them in parentheses. X minus 2 times the log of 5 equals 2x plus 3 times the log of 4. If you don't have them in parentheses, it's just going to look like they want 2 log 5, as opposed to the x also being multiplied by log 5. So this is where this gets a little bit, it looks uglier than it is, because log of 5 is just a gross number. If you had x minus 2 times 4 equals 2x plus 3 times 3, what would you do with the number 4 on the left side? Distribute it, and the number 3 on the left side, you would distribute that as well. It's not pretty, and it's a lot more writing because you have to write the entire word, but we're going to do the same thing. We're just going to distribute the log of 5. So it'll be x log 5 minus 2 log 5. And distribute your log 4. 2x log 4 plus 3 log 4. And I'm just going to use this other numerical one as your side-by-side example. You don't have to necessarily write it down if you want. But if I were to distribute that 4 and that 3, what would I then do if I wanted to solve this? You get all your x's over to one side. So even though this is uglier, that's what we're going to do. We're going to get all of our x terms on one side and all of our non-x terms on the other side. So I'm going to, which side do you want to get your x's on? The left, sure. So I'm going to subtract this x term over. So all my x terms will be on the left. And then my non-x terms, like this negative 2 log 5, I'm going to add over. To the right. So these, are they combinable or no? No, because one's log 5, one's log 4. So x log 5 minus 2x log 4 3 log 4 plus 2 log 5. And so actually, just like that inverse question that we just had on the spiral, if you can't combine these x terms, like 5x minus 3x would be 2x, if you can't combine them, how do you get it so there's only one x in the problem? If you can't combine them, factor them, right? Take out the GCF of an x, and then there's only one x in the problem. And now to get that x all by itself, I just divide that craziness over. And your answer is just this ugly part there. Yes. Unless it says round to the nearest, which it does not. Follow? Not pretty. You can. It's going to be a decimal, but if you can do that too. You can round it to the nearest, like 10th or whatever. So I don't know if I've ever actually played with multiple ways of this, but on this first example, we just took the log of both sides, and that's kind of how we had to iron it out. Because we couldn't take the log base 5, because it wouldn't work on that side. But it's not that we can't do that, it's just it's not as clean as it used to be. So on number 2, I'd like to try that using the log base and pick whichever number, 3 or 7, and see what happens. So just for the sake of choosing one, I'm just going to do log base 3 on both sides. And on the left side, that just cancels. So I have 2x minus 1 equals, now this exponent still comes out in front. Are you with me there? Bring your x plus 1 out in front. And we have log base 3 of 7. So just like we did as our next step here, we'd have to do here, and we'd have to actually distribute that log base 3 of 7. To solve for x's, we still have to get all of our x's on the same side. So I'm going to subtract this one over to the left. And then I'm going to get rid of the minus 1 by adding 1 over. And if I can't combine those two x terms, I'm going to factor out a GCF of x. And then divide that binomial over to get x all by itself. So I don't really know if it's up to you deciding. Do you think either one of these ways is easier than the other? If you do, you can definitely do either way. Taking the plain logs versus taking a log with a specific base. Your answers might look different, but they all should be the same decimal if we did do this in a different way. One more thing on this last one. Why can we not cancel log base 3 of 7 from the top with log base 3 of 7 from the bottom? No. Right, they're pieces of polynomials. You can't cross off. If it was log base 3 of 7 times 1 and 2 times negative log base 3 of 7, and they were pieces of monomials, then you could cancel that and it would be 1 over negative 2. But you definitely can't do this because log base 3 of 7 is a part of a binomial, and same thing with the log base 3 of 7 on the bottom. So you cannot do that, although it's tempting. Okie doke? So, oh, I wish we had another one to try, but we don't. All right, 3 and 4 look totally different. Agreed? There's not really a way to get a single exponential term on the left and a single exponential term on the right like the other two already had. What more do you see when you look at that? The structure of a... What were you saying, Caroline? No, it is. Yeah. That's a quadratic. It's looking different, but this is like the square term. This is like the regular x term, and that's the constant. So just like we would do with a quadratic is we would factor it. So if you were setting up your two terms, What times what would give you e to the 2x? Might you look like you want to take a guess? Just e to the x. Good. E to the x times e to the x. If you're multiplying things with common bases, you're supposed to add the exponents, and x plus x is 2x. Really, it's going to be whatever that middle term is, FYI. And then you need two numbers to multiply to get positive 3, but such that the outer and the inner combo would make negative 4. What are they? Minus 3, minus 1. So the double negative makes positive 3, and then minus 1x is your outer, minus 3, well, minus 1 e to the x, minus 3 e to the x makes minus 4 e to the x. Then you tee it up. And solve. So on the left side, I'm going to add 3 to both sides. I get e to the x equals 3. And how do I get x all by itself? Natural log of both sides. Good. So x equals the natural log of 3. And then teeing up the other one, add 1 to both sides. Natural log both sides. X equals the natural log of 1. Any questions? Do 4 on your own. Brock got the natural log of 7 and the natural log of 1. Did anybody get anything different? Okay, it should look like that. He factors it, tees it up, solves. Okay? So one thing that neither of these examples shed light on, and so I'm just going to steal one of your homework problems, so when I give you your homework, you're not going to have to do 44, is, looks identical. So I'm going to factor this into e to the x and e to the x. Minus 3 plus 1, right? Minus 3 plus 1. And then I'm going to tee it up. What'd you say? Yes. And you get e to the x equals 3 or e to the x equals negative 1. You take the natural log of both sides. And you're going to get x equals the natural log of 3 or x equals the natural log of negative 1. But you're only allowed to take logs of what kinds of numbers? Positive. So you have to know on your own to reject that one because you're taking the log of a negative number. Does that make sense? So you'll only have one answer. Okay? Just took you 1 minute per problem, so the last 4 should take you about 4 minutes. The first 6, and I'll show it to you when you get it. Did I give enough for Mike there? Okay. Just looking at number 1. because one only has the base of 7 on one side and there is no base on the other side, you can just take which log on both sides? Log base 7. So that would be one where, like, our techniques from Friday would be very fast. This one only has one base. So on 40, you're going to take log base 3 on both sides. That'll be quick. And then in 41, you kind of have your choice based on the two ways I showed you. You can do the plain old log on both sides. You can do log base 5, or you could do log base 3 on both sides, depending on what you want. Same thing with 42, and then, oh, I take that back. Yeah, 43 through 48 are very quick. So 41 and 42 will take the longest.